Any other questions over homework? Questions over the homework assignments? So where we stopped yesterday, I believe, was right here. Because I believe we started this one here. We stated that the restrictions were -3 and 3. 7.52. All right, guys. So found the restrictions. We have the denominators factored. So now we need to go through and see what we need to multiply everything by to get the denominators to reduce. So what's one thing we can multiply this equation by? X plus 3. So we're going to multiply all three fractions by x plus 3. Now on the far left, x plus 3 on top and the x plus 3 on bottom will simplify out. Our middle expression. All right, guys, let's focus in. Our middle expression, that x plus 3 will not simplify with anything on bottom because the denominator does not have an x plus 3. And our far right fraction, the x plus 3 on top and bottom will simplify. What else do we need to multiply by? X minus 3. So we can multiply everything by x minus 3. On the far left, the x minus 3 over x minus 3 will cancel out. In the middle, x minus 3 over x minus 3 cancels. Far right, the denominator, there is not one because everything simplified, so the x minus 3 won't simplify. All of our denominators simplified down. We're going to need one more because the middle had two x minus 3s. So we're going to need it twice. All right, guys. Questions on this so far? So this time we needed x plus 3, x minus 3, and x minus 3. We needed it twice because it showed up twice in one of the denominators. So sometimes it is helpful to do it one term at a time to make sure everything simplifies out and we don't have too many terms. And what we're left with, 4x times x minus 3 is equal to x minus 1 times x plus 3 plus 2 times x minus 3 times x minus 3. So this time the least common denominator is x plus 3 times x minus 3 times x minus 3. And once we finish multiplying through, yes. So we could rewrite x minus 3 times x minus 3 as x squared, or essentially x minus 3 squared, but we will need to multiply them out. So we could rewrite this as a single set of parentheses squared, but at this point it might be a little bit nicer to leave it as x minus 3 times x minus 3, since we will have to multiply. Any other questions? Yes. Mm-hmm. So the next main step is going to be multiplying and simplifying these parentheses. Now on the far left, 4x we can distribute through. Our 4x times x, 4x squared. 4x times negative 3, 4 times negative 3 is going to be negative 12. And we still have that x term. Equals. All right, guys. Now we need to distribute or multiply our x minus 1 and x plus 3. So we can distribute the x first. X times x is going to be x squared. X times 3 is going to be positive 3x. Now we're going to multiply with our negative 1. Negative 1 times x is going to be negative x. And negative 1 times 3 is negative 3. Plus, we still have the 2 outside the second set of parentheses. We'll multiply it last because we're going to focus on the x minus 3 and x minus 3. Now our x times x would give us x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 would be positive 9. Questions on this here so far? Now the left-hand side, the 4x squared minus 12x. 4x squared and 12x aren't like terms, so we can't combine. It's pretty much going to stay that way until we finish simplifying the right-hand side. Now on the right-hand side, in this first set of parentheses, our 3x minus x is going to be plus 2x minus 3. Now we can leave the parentheses there, but because there's no number in front of it, no sign in front of it, we don't need it because it's still going to be positive x squared, positive 2x, and negative 3. Plus 2 times. We need the parentheses around this second expression because once we finish combining like terms, we're going to have to multiply them all by 2. Now inside the parentheses, we still have the x squared. Our negative 3x minus 3x, negative 3 minus 3, would be negative 6x plus 9. Well, we still have 4x squared minus 12x. The x squared plus 2x. None of this has changed because the next thing we have to do in simplifying is going to be to distribute that 2 through. We need to finish multiplying this out. So our 2 times x squared is going to be positive 2x squared. Our 2 times negative 6x, 2 times negative 6 would be negative 12x. And our 2 times 9 is going to give us positive 18. Questions on this so far? Now before we can start moving things from one side to the other, getting it equal to 0, we do need to combine like terms. 4x squared minus 12x doesn't have any like terms, but our x squared and 2x squared will combine to give us 3x squared. Our positive 2x and negative 12x, 2 minus 12, would give us negative 10x. And lastly, negative 3 plus 18 would give us positive 15. Questions on how we got to this point? Now, since we do have quadratic terms, we have x squared terms, we need to get this equation equal to what? 0. What do we want to move first? So we can add 12x to both sides. And on the left-hand side, negative 12x plus 12x will simplify out, leaving us with 4x squared is equal to 3x squared. Negative 10x plus 12x, negative 10 plus 12, is going to give us positive 2x, telling us that 4x squared is equal to 3x squared plus 2x plus 15. What would we do next? Minus 4x squared. And when we subtract 4x squared from both sides, our 4x squared minus 4x squared will indeed give us 0. 3x squared minus 4x squared is going to be negative 1x squared plus 2x plus 15. Now, unfortunately, the term in front of x squared is negative, but that's fine, because I try to keep the x squared term, the variable with the biggest exponent, positive as much as possible. And the only time I don't is when it's easier to move everything to the other side, when it's less moves. Here, I would agree, because otherwise we'd have had to move the 3x squared, the 2x, and 15. We moved 3 things here, we're only moving 2. Because even though we do have a negative in front of the x squared, if I factor negative 1 out, we're dividing everything by negative 1, well, it's still going to be x squared. It's still going to be 2x, and it's still going to be 15, because we're really just dividing those, each one of those terms by 1. And by factoring that negative out, we're taking the negative x squared and making it positive. Then our positive 2x is going to become negative, and our 15 is going to become negative. So really all I had to do was factor out that negative. It fixes the signs, and we're good to go. Because by factoring that negative out, we're now looking at x squared minus 2x minus 15. We like that a little bit better than our negative x squared plus 2x plus 15. If the sign of the third term is negative, the signs are opposite. One's going to be positive, one's going to be negative. If that third term is positive, the signs are the same and match the sign of the middle term. Factors of x squared are x and x. Now our factors of 15 are 1 and 15, or 3 and 5. Which one do we want to try first? 3 and 5. Which one do you want positive? 3? 5 is negative. And if we check this, x times negative 5 is negative 5x. Positive 3 times x is positive 3x, giving us the negative 2x middle term we wanted. So now we do have 2 or more things multiplied together to equal 0. So one of these two must be 0. Either x plus 3 is 0, or x minus 5 is 0. One of these two has to be 0. With our x plus 3, we would subtract 3 from both sides, telling us x is equal to negative 3. For our x minus 5, we would add 5, telling us x is equal to 5. But because negative 3 is one of our restrictions, we have to throw it out. It is an extraneous solution. It does not work, because it would make one of the denominators be 0. Yes?
Is there a possibility for
Yes. Yeah, it could be that we don't get anything. That all the solutions that we get are restrictions. And if we throw all of them out, we don't have any left, so it's no solution. Questions on this here? Are you ready for the next one? 9 over x minus 2 plus 6x over x plus 2 is equal to 9x squared over x squared minus 4. We have a term, we have an expression in the bottom of a fraction that's squared, our x squared minus 4. And it will factor. Since we only have two terms being subtracted, we actually have a difference of perfect squares. X squared is x and x, 4 is 2 and 2. So x squared minus 4 would be x plus 2 times x minus 2. Our restrictions are our values of x that would make the denominator be 0. Now there's two main places that it can be 0. And that is when x plus 2 is 0 and when x minus 2 is 0. So if either one of these is 0, it will not be a solution. It's going to be a restriction. So for our x minus 2, we can add 2 to both sides, telling us if x is equal to positive 2, that would cause us to have a division of 0. That doesn't work. With our x plus 2, we subtract 2 from both sides, telling us if x is equal to negative 2. We'd have a division of 0, and it does not work. Questions on how we found the restrictions? Now we need to figure out what we're multiplying everything by. So what's one expression we can multiply everything by? X minus 2. Because then once we do this, we can go through and check. Because the first one, 1x minus 2 on top and bottom would reduce. The middle, nothing will reduce because the denominator is plus, not minus. In our last fraction, the x minus 2 and x minus 2 would cancel. Do we still have denominators? So what else do we need to multiply by? X plus 2. The far left fraction, there is nothing left to reduce on top and bottom. The middle, one of the x plus 2's on top and bottom would reduce. And on the far right, that x plus 2 and x plus 2 would reduce. Do we have any denominators left? No. So we can move on. So it might be helpful to just take it one expression at a time, multiply through, check for reducing, and then check again. Now what we have left is 9 times x plus 2 plus 6x times x minus 2 is equal to 9x squared. And at this point here, we're going to start simplifying. 9 times x is, well, 9x. 9 times 2 is plus 18. 6x times x is going to be plus 6x squared. And 6x times negative 2, negative 12x is equal to 9x squared. There we go. Questions on how we got here? Now we do need to combine like terms. 6x squared does not have any like terms, so it's going to stay 6x squared. But our 9x and negative 12x is going to be negative 3x. 18 does not have any like terms, so it's just plus. 18 is equal to 9x squared. Yes.
Whenever you combine like terms, how do you know like which order to do them?
Oh, or when I rewrite them?
Yeah, no, not that. Yeah.
I mean, when I get here to go squared x. So I try to write it in standard form. Standard form says the variable with the biggest exponent goes first, and then descending order. So we would want to go for here, x squared, find all the x squared terms, put them together first. Then I do x, because it's one power less, and then constant term. And I write it this way, especially if we're going to factoring, It helps me line it up for first and third term. We can actually start our factoring process. But the actual ordering of terms, how I combine them, really doesn't matter. It's just how am I going to be able to organize them to best use them is the main goal. Does that kind of answer the question? Okay. Yeah, because we normally start biggest variable and work our way down. And I always write something underneath just so I can visually see that, okay, 6x didn't have anything, 18, but I can jump back through and see, did I actually combine my terms? Did I actually take count of everything? For here, it's not too bad. When we start getting 10, 12, 13, 14 terms written out, it's easy to lose one. Good question. Any other questions? Now we need to get this equation equal to 0. And again, I try to keep essentially here the x squared term positive if I can. But I wouldn't necessarily want to move, subtract 6x squared, add 3x, subtract 18. I don't want to move 3 things across when we can do what? Subtract 9x squared. I move one thing, I get it equal to 0. Now the downside is 6x squared minus 9x squared, negative 3x squared. But as we saw with the last one, I can factor that negative out. I can remove that negative. And actually, there is another greatest common factor, and it's going to turn that first term positive. So before we finish factoring the negative out, is there something in common with 3x squared, 3x, and 18? 3, yes? So if we factor 3x squared, or 3 out of 3x squared, we would have x squared. And since I'm factoring the negative out, it's going to turn it from negative to positive. Our negative 3x, well, factoring the negative is going to make it positive. We're going to factor the 3 out completely and leave us with x. Now with the 18, we'll take care of the sign first, because since it's positive, I pull a negative out. It's going to go to negative, and 18 divided by 3 is 6. Two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 6 are 1 and 6 or 2 and 3. Which ones do we want? 2 and 3, which one do you want positive? Well, we just pick one. Because again, the last thing we're going to do is check and make sure that we get that middle term. X times negative 3 is negative 3x. 2 times x is positive 2x. Negative 3x plus 2x is negative x. We wanted it positive. Switch the sign, so now we get positive 3x minus 2x gives us the x we need. Yes. Questions on this here? 2 things multiplied together equals 0, so one of these has to be 0. So we're not worried about the negative 3 because it's just a scalar. Now, x minus 2 equals 0, we would add 2 to both sides. X equals 2. For x plus 3, we would minus 3. Which one are we going to cross out? I'm trying to remember what our restrictions were. 2 and negative 2. So the negative 3 works because it wasn't one of our listed restrictions. Now the previous one it was.
Yeah, I don't know.
No. The previous two problems, the restrictions were 3 and -3. This one it switched over to 2. Like we were saying earlier, if -3 had also been a restriction, it's just no solution. Now, especially when it comes to the test, even if one of them is a restriction, I still want it listed. It's just we put a big old X through it showing that we know that it's a restriction, we throw it out. So the restrictions are any value of X that would make the denominators be 0. Because here we said 2 was a solution. So 2 is a solution. We found that. So if I plug it back in, we'd have 9 over 2 minus 2. Well, 2 minus 2 is, I can't have 9 over 0. We have a division of 0 error. Because positive 2 would make this and actually this be 0. So I throw it out. It is a restriction, it's a value of X that would give us a division of 0. So we list it at the beginning, and especially for these here, I say, okay, X cannot be these values, so that when we come down here, oh, I got 2 as a solution, we know it's not going to work back at the top. It's not going to work where we started, because it would make one of these be 0. And that helps us in that when I get down here, I don't have to check -3 and 2 to make sure that they work. Because I listed that -2 or -2, this is going to cause that division of 0, is going to cause an error. Questions? Other questions? We have one last one that we're going to do. I'm going to go on and factor that for us, because the only one we need to factor was the x squared minus x plus minus 2. So our restrictions, I think another way to think of it is what's going to cause that division of 0? What's going to cause the bottoms of these 3 fractions to be 0? Kind of another way to think of it. What's a value of X that's not going to work? That's going to cause problems. And so we would look at the denominators. So one of those expressions that we have on bottom is X minus 1. And if it's equal to 0, that's not going to work. We also have X plus 1. And actually for this one we have a third one. We got 3 of them. Now for X minus 1 we would add 1. If X is equal to 1, that's not going to work. Minus 1 telling us that X is equal to -1. We'd have a division of 0. So here X cannot be 1, -1, or 2.
So literally the only thing we have to do to find it is write it out.
Yeah, find what's going to make those be 0. Now, I'm just going to start with X minus 1, because here, cancel out, and that's it. Thank you. And then we need X minus 2. Right, so here, and so when we go back to rewrite it, so I have 2, x plus 1, x minus 2 still being multiplied. Or the x minus 1 on top and bottom cancels. And the next one we have 1 times x minus 1 times x minus 2 left on top. I'm not going to write the 1 because that's understood. And we have that left. And the last one's just x minus 1. Because the last few times I've been writing it on this diagonal, but really that whole thing, 2 times x minus 1 times x plus 1 times x minus 2, is all on top over the x minus 1. Instead of us rewriting all fractions with that written out on top, we're kind of just skipping that step and just saying we know these cancel, giving us this here. Now at this point here, multiply your parentheses together first. So I would not worry about multiplying with this 2 until we finish the parentheses first. X squared minus 2x plus x minus 2 plus x squared, 2x, negative x, yes. Yeah. Now on the right hand side we have x minus 1. Is there anything with it? So it's just going to be x minus 1. Now we can combine like terms. So for that first set of parentheses, the negative 2x plus x is going to give us negative x. Plus negative 2x minus x, negative 3x. Do we really need those parentheses around that second one? No, because the number in front of it's 1 and it's positive, so there is no sign change. But we do need to multiply this 2 through. 2 times x squared is going to be 2x squared. 2 times negative x is negative 2x, and 2 times negative 2 is 4. Now we can combine like terms. Now we start just with the biggest exponent. So 3x squared. Negative 5x. Yes. Now that we have our like terms simplified, we need to get this equation equal to 0. So what can we do first?
Or plus 1.
Add 1.
Down to x squared minus 5 x minus 1
Mm-hmm.
or equals x. Now give me x squared minus 1. Oh, wait. Oh,
Yeah.
okay, it's negative, yeah.
Yeah, so minus 6x minus 1. Is there a greatest common factor between these three terms? And it's also looking like there's not a good way to get the factors of 3 and 1 to make it be 6. Quadratic formula. Well, looking at the quadratic formula, because again,
Wait, can we? I thought we could just do
we could try, but unfortunately it's not going to give us factors of the first and third term aren't going to work together to give us 6, unfortunately. So we're going to have to use the quadratic formula to get there. It doesn't factor. What is A for us? B is C. So we're going to take those values and plug them in. So x equals negative b. Well, we said b was negative 6. Plus or minus the square root of b squared, so we'd have negative 6 squared, minus 4 times a, well, a is 3, and c is negative 1. So really, we just took the values of a, b, c, and plugged it in across the top, over 2 times a, which would be 2 times 3. Questions on how we got negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 1 all over 2 times 3. Now at this point here, this is when I would get the calculator out for the most part, because negative 6. The negative and negative makes positive. In the denominator, 2 times 3 is 6. Now the first thing I'd plug in the calculator is what's inside that radical. So negative 6 squared minus 4 times 3 times negative 1. 6 squared minus 4 times 3 times so it tells me what's inside that radical is 48. Now we do want to make sure that doesn't simplify. So we can say second square root of so it simplifies. Square root of 48, 4 squared to 3. We get 6 plus or minus 4 squared to 3 all over 6. And this is the final answer as long as the top two numbers and the bottom number don't have something in common. So 6, 6, and 4 are all divisible by what? So since all three spots, the top two and the bottom, have a divisibility of 2, we can divide that out. The top 6 divided by 2 is the plus or minus 2 square roots of over. Now that 1, 3 on top and 1, 3 on bottom do have a common factor of 3, but because the 2 outside the radical, we don't care what's inside, outside, is not, this is the answer. And we actually have 2 because we have 3 plus 2 square roots of 3 and 3 minus 2 square roots of 3. Is either one of those our restriction? Yep. So that's it. That is the answer. Because up to this point, we've had this kind of tendency that the quadratic formula is something huge, scary thing. But really, it's just plug A, B, C in, simplify. 2. 6 problems, 2 of them are going to require that quadratic formula. But especially homework, whatnot, write it out. Because if you show me your work, the steps, I can go through and see if there was an error or mistake and fix it. So that way when you get it back, you'll see what it is. And especially on the test, if one of those comes up and you need to use quadratic formula, show me it written out.
I know what that is.